Okay, I'm Justino Rodriguez. I'm going to show the variables and the read potentiometer function. At first, we have the int channel 1 DC, that is the CCRX. Then this unregistered integer, that is the analog input, that is the reading from the potentiometer. Then we have these two floats, that is the value for counterclockwise and the value for clockwise directions, that are both used to map the readings from the potentiometer to the PWM for the motor. And then the read potentiometer function, that is described here below. Here. At first, it starts and it takes the reading from the AD converter. Then it proceeds to make the conversion, and it then gets the value and it stops. This value is taken in this variable for making debugging easier.
So here, every time we start the while loop, we read the potentiometer, which gives us a new value of the analog input. Then we check the analog input if it's below, over, or in between 2000, 2014, or 2400, and then we change the direction of the motor respectively to what the point is. And when it's in between, we get directly the value of CCR to 0, so there's the 0% duty cycle. To convert the duty cycle in the clockwise configuration, the counterclockwise configuration, we read we subtract from 2000 the value of analog input, and then this variable, that it's a float with a value of 1999, it's divided in to get a percentage to get the duty cycle, and then we multiply by the 36,000. So we in CH1 we get the CCR value, and similar here we get the analog value. We subtract 2400 and we do the same trick to get the duty cycle in this part, and then multiply by the 36,000 ARR value, so we get the correct TCR value of the in the program, and this will give us the trapezoidal figure depending on the analog input that the project requires.
Well, my name is Jaime, and this is the schematic for the physical connections of this activity. Here we have the potentiometer. We have a voltage divider that is being read in this pin. It is being fed 3 volts and it is connected to ground. So it sends a signal. Then we control the H bridge with this set of pins. We send an input 1 and input 2, which are just 1 and 0s, and we can flip them, and that will flip the voltage. And the enable is where the PWM signal is entering the H bridge, and then this is the voltage to feed the H bridge, and this is the motor being controlled.
Básicamente de que el duty cycle para
Hi, I'm Alejandro, and finally I'm going to do the demonstration. Right now the motor is off, since as seen here in the live expression, the potentiometer value is around 2000 to 2100. So well, I'm going to start turn the potentiometer to that side, and the motor will turn to that side too. Well, first slowly, and then I increase it. It goes to maximum velocity. Here at almost 100%, can be seen the duty cycle in the oscilloscope too. And I'm going to lower it, and the duty cycle changes accordingly. The same as the values of the live expressions in here, which are near to the specified range. Now to the other side, the motor turns to the other side too. And the duty cycle changes, and the motor direction too, as in here. Thank you.